Why do carbon monoxide alarms use electrochemical sensors? Imagine a tiny device that can detect a silent, invisible threat in your home or workplace before it becomes dangerous. That's what a carbon monoxide alarm does, and the secret behind its accuracy lies in its electrochemical sensor. These sensors are specially designed to sense carbon monoxide gas very precisely, even at low levels. This is important because carbon monoxide is a colorless, odorless, and tasteless gas that can cause serious health issues or even death if it builds up unnoticed. Electrochemical sensors work by using a small cell made up of 3 electrodes: a working electrode, a counter electrode, and a reference electrode. When carbon monoxide gas enters the sensor through a tiny opening covered with a gas-permeable membrane, it reacts chemically at the working electrode. This reaction produces electrons, which generate a tiny electrical current. The amount of current produced is directly related to how much carbon monoxide is present in the air. The sensor's electronics then interpret this current to determine the gas level accurately. The design of these sensors includes a diffusion barrier that controls how much gas enters, making sure the readings are stable and consistent. Inside, there is an electrolyte, often sulfuric acid or potassium hydroxide, which helps carry the electrical charge. Noble metals like platinum or gold act as catalysts to speed up the chemical reaction, making the sensor more sensitive and reliable. The reference electrode keeps the voltage steady, so the sensor can measure changes accurately without interference from other gases or environmental factors. Using electrochemical sensors in carbon monoxide alarms is essential for fire safety because they respond quickly to dangerous levels of CO. This fast detection allows people to evacuate or take action before the gas reaches harmful concentrations. These sensors are also energy efficient, which means they can run continuously without draining power, making them perfect for homes, offices, and firefighting equipment. They can detect parts per million levels of carbon monoxide, helping prevent poisoning that can cause headaches, dizziness, unconsciousness, or worse. Another reason these sensors are so effective is that they include protective filters and membranes. These components help prevent false alarms caused by dust, humidity, or other gases, ensuring the alarm only sounds when there is a real threat. This reliability is vital in fire safety systems, where false alarms can cause unnecessary panic or desensitize occupants. In firefighting scenarios, the quick and accurate detection of carbon monoxide helps responders assess hazardous environments. It also protects residents and workers by providing early warnings of dangerous gas buildup. Because of their sensitivity, stability, and ability to operate over long periods, electrochemical sensors are the best choice for modern fire safety systems. They help save lives by ensuring that dangerous carbon monoxide levels are identified promptly, giving everyone more time to stay safe.